Hello and welcome to the second episode of Artistry of Code Snippets. My name is Artur and I am your host today. In the next few minutes, I will try to find the answer to the question: what is the unit of unit test? What is worth having a separate test and what is not? Is there a golden rule that helps us decide? We want to make it short, so let's start. It's unclear when the culture of automatic testing started. There are reports saying that unit testing has been possible since the 80s, but it became popular around the late 90s or year 2000, together with the birth of JUnit and Agile Manifesto. Now, over 20 years later, we are already familiar with concepts, technologies, and methodologies that derived from it. Test-driven development, code coverage, test pyramid. There are lots of tools, frameworks, and libraries that aim to make the testing an enjoyable experience. Even though we live with automatic testing concepts for so long, yet still their definitions are not precise enough, so we can have those coffee break discussions about tests and their classification. I don't want to make the whole review of all automatic tests today, but rather focus on those that we're probably the most familiar with: unit tests. Let's start with trying to say what they are. As I have mentioned, you can find plenty of different definitions of unit testing that might slightly differ, but we can find a few common attributes. Martin Fowler, in his article from 2014, did that for us and specified that unit tests: 1. Are focused on low-level pieces of code, 2. Needs to execute fast, and 3. Are written by programmers. Despite the commons, there are also differences. Mr. Fowler underlined the understanding of the unit as the primary difference. That is the aspect that I want to focus on. So, what is the unit? Our first thought might be to associate the unit with some notion of code. It can be either class, function, procedure, or other building block of the programming language. That's a natural reflex to think that's the right thing. Usually it's a good intuition, because the intent of having a function, for example, is to wrap a series of lower level activities into a single higher level action. Yet, we shouldn't end up on that statement. It might happen that our function is big and complicated or does more than it should. For example, executes more than one high-level action or contains statements of different level of abstraction. It means that we didn't do our homework and messed up the separation of concerns. Well, it happens to the best of us. But even if we missed that while writing the code, we should be able to spot that design flaw when writing test cases. Just imagine how much time we can save writing tests first. Having that in mind, I would propose to think of a unit as a notion of code that executes the single action on a given level of abstraction. So, is every unit worth being tested? Purists would answer yes, without hesitation, but I consider being pragmatic as a better attitude. Our beloved Uncle Bob, Robert C. Martin, in his blog post from 2013 called The Pragmatics of TDD, listed a few examples of code that he's not writing tests for. 1. Getters, setters, and member variables, because they will be indirectly tested by objects' behavior tests or tests of logic that uses them. I would also add to this point simple constructors without any business logic and data structures. 2. One-liners or small functions with trivial logic. 3. Graphic user interface functions, but with regard that GUI elements only trigger the business logic implemented in a testable way. And 4. Third-party software that is supposed to work, like SDKs, frameworks, ORMs, third-party services clients, etc. Even though there was a time that I have been crazy in love with unit testing, now I fully agree with that pragmatic attitude. Basing on my experience, to that list I would also add 2 more items. 1. Abstract classes with pre-implemented methods or PHP traits, because its final implementations most probably have its own logic built upon abstract members that needs to have its own test suite. 2. Helper functions, so specific so that it can only be used in a single place. Most probably they will be indirectly tested by a higher level logic tests. Regarding the latter, there is a concept of writing sociable tests over solitary tests proposed by J. Fields in the book Working Effectively with Unit Tests. Let's say we have a piece of code that delegates some actions to collaborators. We can either go to the solitary way, mocking all collaborators in our tests and testing them in separately, or choose the sociable test, providing genuine collaborators and testing the whole flow together. Decision which way to choose should be made independently every time. I have been talking a lot about situations where unit seems to be too small or too trivial to be tested, but what if we end up with the test suite having hundreds or thousands of lines of code? Well, I think the best way is to reduce the complexity of the unit. Maybe we can extract some logic to the collaborator unit and test it solitarily. Maybe our unit is doing 2 things instead of just 1. Let's apply the single responsibility principle and separate those responsibilities to distinct units. Maybe the unit is given a collaborator that is too generic and we need to make lots of effort to mock it. Ensure you're using the dependency inversion principle with minimal interface required to do the job. Sometimes the source code of the test itself can be tweaked. Maybe there are very similar test cases that differ only by parameter values. We might use advanced features of test frameworks like each loop of jest or parameterized test of JUnit. Maybe we're running the same assertions in multiple test cases. Test framework usually allow us to define our own assertion function that we can reuse. Unit tests are here with us for over 20 years, yet still there is so much to discuss on how to write them right. There are lots of standpoints and opinions, but all of them have a good intention to make our codebase a safe environment to work in. Remember to keep your tests clean. You don't have to be a purist, but don't let yourself treat them freely. Be wise and make deliberate decisions over your testable units of code. The future you will thank you for that.